A last one in chapter 8, surprisingly. We're going to solve rational equations and also find their inverses today because it's kind of the same thing. But let's get started. Okay, so we're going to cross multiply, which is going to bring us back to like middle school stuff, right? You cross multiply and divide. We're not going to technically divide. We're going to cross multiply, FOIL, and then solve. But that doesn't sound as cool. So to cross multiply, what we're going to do is we're going to take across. We're going to multiply across from the equal sign. So we're going to do x plus 2 times 10. Now, here's what I really want to do. Is I want to write it like that, but you know what that looks like? It looks like I'm only multiplying the 2 by the 10 when it's the whole thing. So I do parentheses if it's on one thing together. And that's going to equal the other thing. Some of you were taught to do it the other way, like you do this first and then that. It doesn't matter. So we're going to do 2 times 3x plus 2. Here's algebra. Let's do it. Let's just do it. But really quick, I can't divide by 0. So my answer should not be -2 or -1/2. No, -2/3. I can do math. I know that would be 2/3 because I equal this to 0. Subtract 2 divided by 3. That's 2/3. It's not going to be important in this one, but I just want to get you used to the idea that it can't be where I divide by 0. It's impossible. We can't do that in math. Okay, so I'm going to distribute this. So I get 10x plus 20 equals 6x plus 4. And then I'm going to continue to solve by subtracting 6x from both sides. So 4x plus 20 equals 4. And then subtract 20. So 4x equals -16, and then divide by 4. X equals -4. Cool. That was not in my restricted domain of -2 and -2/3, so I'm good. I checked my work. Okay, let's try another one. All right, let's try this one. Now, you might notice that there's more x's in more places, so I actually might have more than one answer, but I'm going to do the same math again anyways. So I'm going to do cross multiply. Okay, so I'm going to do x times 2x plus 5 equals 1 times 11x plus 8. And I can continue solving from there. If I distribute this x, I get 2x squared plus 5x equals 11x plus 8. So I have an x squared, so I probably have 2 answers. Let's just see what they are. Now, in the last one, I only had x. I had normal x's, no x squareds, no x cubed, no x square roots. I don't know. So I just solved this with normal algebra 1 level. This one, because I have an x squared, I have to solve it according to unit 3 or 4 whenever we did quadratics. So I need to move everything to one side so that it equal to 0. So I'm going to subtract 11x from the 5x and subtract the 8, just chilling over here. So I get 2x squared minus 6x minus 8 equals 0. Now, I don't like this 2 in front, but luckily I can divide everything by 2 and I won't change the problem at all. So I'm just going to do that. Let's divide everything by 2. This doesn't work all the time. It just works if it's a 2 and then a multiple of 2, and then a 0. So that's why I did it. X squared minus 3x minus 4 equals 0. That's a quadratic. We know how to do that. We can factor it. Also, most of you on your midterm said you prefer factoring, which makes me so happy because most people hate factoring, except for in my class because I do it right. Okay, so what multiplies to get -4 and adds to get -3? 2 times 2 doesn't work, so it must be 4 and 1. And then to make a -3, I need a -4. So this will be x minus 4, x plus 1 equals 0, which means my answer is x equals 4 and x equals -1, both of which work in my equation. Sometimes we'll have extraneous solutions where it doesn't actually work. Like when I said back here, if it was -2, then I would have no answer, or I'd only have 1 if there was 2 options. But, sorry, 4? Okay, 4 and -1 both work in this equation. Oh, okay, I hurt my head a little bit. Okay, so to find the inverses, we've done this before. If you remember, last time we did this, we switched the x and the y, and then we solved it for y. So we're going to do the same thing here. So for example, We want to find the inverse of this. I drew a dotted line because this is the second part. It's inverse is not solving, but it's still solving. It's fine. Okay, so what we're going to do is we're going to replace this one with an x and replace this one with a y. So here's what that looks like. We're going to say x equals 7 over y plus 5. And then I just have to solve this for y. So I want to say y equals at the end. So we're going to do that same multiplication we just did. This is kind of like an x over 1. So when I multiply that, actually, no, we're not going to do that at all. Just kidding. We're going to multiply by y plus 5. So I get y plus 5 times x equals 7. Then I'm going to divide both sides. Hold on, let me just... Okay, divide both sides by the x because I want the y to be alone. So y plus 5 equals 7 over x. When you do this enough times, you realize that all we just did was we switched this x with this whole y plus 5. We just switch-watched them. That's not a thing. And then I'm going to subtract 5 to be over here. So that's not going to be 2. It's just going to be 7 over x minus 5. Also, we normally rewrite the y as an f inverse. Oops. So I actually should have written f inverse x equals 7 over x minus 5. That would have been better because it's not really y anymore. It's a whole new world. It's right at the bottom of the page. I'm going to write steps and upload these, but that's all you have to do to find the inverse. Do we have to state the domain? No, we're good. Okay. Good luck. Email me if you have any questions.